examples on the worksheet, but we're going to be solving single square root. And I did spell that wrong, didn't I? So a single square root equation means it just has one square root in it. Okay, here's an example. 2x plus 7 equals 8 minus the square root of 5 minus x. Down here, I have the square root of x minus 1 equals 5. There's only one square root in it. You guys could probably solve this one. Square root of x equals 7. What do you think x would be?
49.
49.
Yeah.
The square root of 49 equals 7. Okay, together we have x equals square root of 7x plus 15. And then I made it very clear that the minus 1 is not inside the radical. Okay? And we've already got step 1 on here, so let's read it. Move all the non-square roots to one side of the equation. Okay? That means I'm going to take this minus 1 and move it over here because it's not a square root. That way I can get the single square root by itself. So since it's minus 1, we're going to add 1 to both sides. And so for the first step, we have x plus 1 equals the square root of 7x plus 15. Which is just, step 2 is just making sure that the radical expression is on the other side of the equation. So you got your radical on one side, everything else on the other. Okay, but like you said, in order to get rid of a square root, the opposite of that is squaring it. Let me actually demonstrate on another piece of paper. For example, let's say we had the square root of 9 squared. Okay, suppose we didn't know that rule, that they cancel each other out. What is the square root of 9? 3, right?
Oh.
And then if you square 3, you get the same thing you started with, right? So basically, you could have just canceled the square root out with the square and just got 9. Works with any number, just undoing what you already did. So this is step 3. You're going to square both sides. Now notice, you want to put parentheses around both sides, especially when there's 2 terms on the left. When you square the right side, it's going to take care of that square root. You're just going to be left with what's on the inside, which is 7x plus 15. Now let's talk about the left, though. How come we can't just distribute this 2 to the x and to the 1? It's because of this plus sign, actually. When you square something, like he said, you multiply it by itself. So in order to square a binomial, you have to multiply it by itself, x plus 1 times x plus 1. And then you have to FOIL. Right? So you have to multiply the first terms, that's the f in FOIL. X times x is x squared. Multiply the first times the last, that's x. I is inner, so 1 times x is x, and 1 times 1 is 1. So you're going to end up with x squared plus 2x plus 1 on the left, and again on the right, the only thing that happens is the square root cancels. The next step is to solve. Now I'm reaching back to a previous lesson. So what kind of equation is this? Starts with a Q. Quadratic. Why? Because x squared. Okay? When you're solving a quadratic equation that has all 3 terms, a quadratic term, a linear term, and then a constant, you have to move everything to one side. Okay, I know it's been a while, but we did this. You want to get everything on one side of the equation. So we're going to subtract the 7x and the 15. We're going to end up with x squared minus 5x minus 14. The next step from there, that's equal to 0, by the way, because everything moved to the left. The next step from there is to factor using the x method. So I'll go back to this slide, but x squared minus 5x minus 14, what goes on the top of the x? I'll give you a hint. The leading coefficient is 1. Yes. A times c goes on the top of the x. What about the bottom? Negative 5. Okay, so where are we at here? Okay, 2 numbers that multiply to give you negative 14 and add to give you negative 5 is negative 7 and positive 2. All right, so that's how I got x minus 7, x plus 2. All right, the next thing you want to do, again, I'll go back to this slide, is set each factor equal to 0. So we're going to have x minus 7 equals 0, x plus 2 equals 0. Okay, so on the left, you get x equals 7. What will you get on the right? There you go. Okay, so that's how I got that. I was just showing some more work there. Now, you would think you're done, right? You got x equals something. You're solving an equation. With square root equations, you have to plug them back in. Yep. All right, step 5 is to check for extraneous solutions. An extraneous solution happens when you plug a number back into an equation and it doesn't work. And I will demonstrate and I'll explain why. So let's plug in the 7 that we got, x equals 7. That's weird, that just disappeared. When you plug in 7 back into the original equation, you'll get 49 plus 15, which is 64. Take the square root of that, you get 8. 8 minus 1 is 7. It checks out, okay? So it's not extraneous. It works. You can circle it. Over here, however, color here. The other solution we got was x equals -2, okay? 7 times -2 is -14 plus 15 is 1, right? The square root of 1 is 1. 1 minus 1 is 0. It doesn't work. -2 does not equal 0. So we call it extraneous. Okay? There is another way you can get an extraneous solution. And that's if you ever plug a number back in. Okay, let's say you just have this expression, square root of x minus 3. And for whatever reason, you solve this equation, you got x equals 2. When you try to plug in 2 in for x, you get the square root of a negative number, which you can't do, right? You can't take the square root of a negative. In that case, it would also be extraneous. Okay? So that's the two possibilities of extraneous solutions. Either the equation doesn't work out or you get the square root of a negative number. That's it.